Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome to our new chapter, Air Jet Weaving. In this chapter, we will try to understand how air jet weaving works, how it is different from other web insertion systems, what are its benefits and limitations. We will try to compare it with other air jet system, and we will try to understand the basic technology that required to insert the web. And we will also see what different components of air jet weapon session are, how they participate in weapon session, their working, and we will try to also summarize the settings required for different components and their detailed parameters that are required to set for proper air jet insertion. Now let's start it. Today we will include this first module of this air jet weaving that is about the most introduction. In today's lecture, I'll try to introduce you the basic working and the working of different components of air jet weaving. Air jet weaving basically is the way of inserting the weft with the help of compressed air. The weft is introduced in a stream of compressed air, and this high-speed air stream takes the weft from one side of the machine to the other to insert the weft. Here is the animation of the working. I will show. You will see here. There on the left is the winder, from where the yarn will be uh, introduced to the main nozzle. Actually, there are two main nozzles, but here is only shown one. And then from this main nozzle, the yarn will enter into the channel where it is boosted and accelerated by the sub nozzles, and the yarn will be, and the air pressure will be released to have the tip of the yarn accelerated in forward direction so that it reaches to the other end of the fabric breadth. So let's see the animation and then we'll continue the next slide. Since we have seen the previous slide that the weft will carry the air will carry our weft from one side of the machine to the other. Here I'm going to describe you what different components are, and I will let you illustrate how they contribute in the web insertion. So the most common way of employing the air jet weaving process is use of multiple nozzles. Multiple nozzle systems, and with the help of profile reel that provides the channel in which the yarn can be flown, or inside or a channel where we blow and take the yarn to the other side of the machine. So the basic component will be the yarn will be supplied from yarn package, like shown over here, and the yarn will be available on the creel. In actual, that is not a variant over here, but yarn will be supplied, and through different guides and tensioners and sensor, the yarn will enter into our weft feeder. This weft feeder is available with the ability to coil the yarn on its dial, and intermittently it can release the thread as required for each next weft insertion or next bit insertion. So then we have over here here is the yarn brake. This yarn brake helps to maintain the tension of the weft. It homogenizes the tension of the yarn so that weft yarn don't feel very high tension, and prevent the yarn from breaking. From here, the yarn will enter into our first main nozzle, that is called tandem nozzle or fixed nozzle, and from here the yarn will be Yarn releasing from our pre-winder will enter into our first nozzle, that is the main nozzle over here, the fixed first main nozzle that is fixed, also called tandem nozzle. Then the yarn will be guided on, from here it will be fired upon, or it will be guided to the other nozzle, that is main nozzle. It is fixed on this way and moves with the read forward motion on it, backward motion on it. And this is the major, our major nozzle that will provide the initial acceleration. Both these two nozzles will provide the initial acceleration of yarn, but their pressure is not sufficient to carry the web to the other side of the machine. So we need the assistant, and this assistant is provided by the sub nozzles or relay nozzle, that is there 4, 5, 6, even 3, 4, 5, 6. And these nozzles will provide only pressure when the yarn is in front of them, so that the tip will be accelerated, and the yarn behind this follow this tip acceleration until it reaches to the rightmost position, from where it is stretched. Even after the peak has been settled, it keeps stretched in stretch form with the help of this 7-number nozzle. This is called stretch nozzle. We have two detectors to detect the presence of yarn. One is called, this is weft detector 1. Then we have here the weft detector 2, WF2. These two detectors, one function the presence of yarn and one function for the absence of yarn. If their working deviates from their set position, the weft will not be perfectly inserted and machine will stop. So the all this working has been the pressure release has been controlled by different type of uh, solenoid valves over here, 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 and here. These solenoid valves can open or shut down, like shown over here. This is showing the tandem nozzle release and stop. Then we have over here the time period for which the main nozzle will start and stop, and then the sub nozzle, their timing over is here the overlap is high, here the overlap is less, so it will reach on the other side. So this graph that shows when some nozzle opens or closes can be controlled from the computer of the machine, and also this can be controlled automatically, so that our weft is reaches on the other side within the time and using the least resources, also that our weft insertion will be have optimum pressure and optimum use of the uh, pressure release, so that there is no wastage of the air, compressed air, and also not very high uh, pressure is adjusted on the machine, so that at the minimum pressure or the minimum time, that is the optimized uh, uh, timing, and the amount of air pressure is used on the machine for each peak, so that we can have we do not waste the energy and we have optimum quality of our fabric. In previous slide, I have already explained you the air jet wave insertion. For the sake of the slide, I just will just mention you again what we discussed in the previous slide. I will continue from there. So we already see that the filling yarn by we see that this is stopper over here. This stopper stops the breaks the weft when one pick is inserted. It applies the brake slowly, so that there is no high tension increase in yarn suddenly, so that yarn do not break. Uh, from here, the yarn is fed to this tandem nozzle and this main nozzle. They both provide provide our initial acceleration. Then the yarn is presented to the relay nozzle in the channel of the reed, and this channel and pressure from the relay nozzles 3 number, 4 number, 5 number, 6 number release the pressure, and this tank 3 is shown in yellow. This is the stretch nozzles. These the last node, these are the last nozzles, so they have less distance, as well as the initial nozzles have less distance, so that they have consistent pressure on the yarn, and it does not deviate from its position. From here, at the last one, the 7 one is the stretch nozzle that keep the pressure in the yarn so that the yarn remains straight. And in this straight position, the yarn is cut from the receiving side, almost from here, so that this cutting is very important. Otherwise, if the cutter is not working, the next weft insertion will not insert only one yarn but two yarn, because yarn is not cut from here. A loop will move forward, not the cutted end of the yarn, end of the yarn. So it is very important the yarn is cut after every pick. So this is all about what is the mechanism of inserting the weft yarn for the air jet weaving. So we are here in the next slide. In this slide, I want to mention the feature of air jet weaving. Let's talk about the air jet weaving machine combines high performance with low manufacturing requirement. So air jet weavings are very popular because of their very high performance. They can perform consistently above 90% efficiency. This efficiency is with respect to the time. The 95% uptime means more production of the machine. The other thing is in the high performance that counts in the high performance is their high rate of weft insertion. These days, this weft insertion rate has increased to 3000 meters per minute. That is very high. And also the requirement in the form of manufacturing is very less as compared to the other weft insertion systems. For example, in repair we need more space, and there are a lot of mechanical parts, and that is why its requirement for as a weft insertion system are relatively very less. So that is why it is very popular. So it's the other thing I want to talk about the features of air jet weaving is due to its exceptional performance. Air jet machines are used primarily for economical production of standard fabrics. Yes, this is I want to explain this point is they are mostly used for such type of fabrics that are simple to produce in large volumes, that required consistently machine running at high speed without interruption. So for the regular fabrics, it is very popular to use the air jet weaving. No doubt, there are other type of fabrics that are becoming very popular for specific application like denim fabric manufacturing or terry fabric manufacturing, and now technical fabrics that will require glass fabric to be inserted and tie cords. So it's gradually the air jet weaving is entering into the other markets that are beyond just the normal fabrics. So it's becoming very popular. So air jet manufacturing is very simple, and one more feature is its simplicity. It means that the air jet weapon system require only a very small amount of air, compressed air, to pass from one side to another. That is very simple as compared to any other weapon system. For example, projectile, you fire a bullet with the yarn in the tip. Its tail, and for the rapier you need to these grippers that mechanically moves in the shed. So as compared to those other air jet systems, air, air jet presentation is very simple, that requires only to blow the air. So this simplicity it makes it more easy to maintain mechanically by maintenance wise, and less parts involved, less wear and tear involved, more consistent working from the machine, easy change of styles from one to another. So these all things make air jet weaving simpler than the other differentiation systems used for the fabric manufacturing. So the components we have already talked about, that are nozzles, spray, profile weave, and this all makes a relatively simple design to follow. Like already told you, again the mass that required to pass through from one side to another for the purpose of inserting the weft is very small. That is only 1.5 gram mass is transported for each wick, as compared to if you compare it to shuttle, where we require 600 gram of the shuttle to be inserted, average 600 gram to be moved from one side to other side of the machine for the insertion of the weft. So it is also saving our energy, that we require less energy for each pick to insert the web. We have already talked about that mechanical parts are less involved in air jet weaving. So all these features of air jet weaving make it more suitable and acceptable in industry. That is why air jet is very popular in these days. Now let's talk about some more related thing about air jet weaving. Let's talk about the advantages. The air jet weaving is high productivity. I talked to you about in the last slide that we can have continuously running of a machine about 90% efficiency, 90% of time. So it gives a high productivity, and also the absorption rate is very high. These both things add to the high productivity of the machine. We require relatively less space to accommodate our machines on the floor as compared to the rapier machine or the projectile machines. So for the same space required by the number of machines, in the case of rapier, we can accommodate more machines. So the space requirement is less. No doubt we require a separate compression, air compression, and also the air conditioning system to have our compressed air be available and cool. And other advantages of air jet involve the high insertion rate. There are less moving parts, so we have less operation to insert the weft, less chances of getting hurt by the workers. Hazards are less. Wear and tear would be less. So this all adds to positive points to the air jet weaving. Noise level is comparatively less because machine mechanical part are less moving, so we have less noise. No doubt this noise, still the noise level is too high, and we need to arrange air muffs to reduce this to for human workable conditions. Due to less movement of the requirement of the parts, less wear and tear, we need less spare parts, and also we require resultantly less maintainability because of parts are less. For air jet weaving to be working, we require some prerequisites. For example, the source of air, cooled air. Generally, the air that is consumed in the shed is 6 bar for each machine. So we have to accommodate the pressure higher than 6 bar so that we can build pressure as the requirement of the machine. And also we need it cool down to acceptable range of room temperature, that is almost 25 degrees centigrade. We cannot process all type of wefts on air jet weaving. There are some limitations of weft requirements to be processed on the air jet machines. So the yarn that has very low twist spun yarn can be difficult to insert because it can untwist and its parts can break away, and inconsistent wefts and insertion will be done, or it will have problems in weft insertion. Also, we cannot use very heavy or special type of yarns to carry the weight of those yarn to the other side of the machine. So all type of weft insertion is not, the spectrum of wefts that can be inserted by the air jet weaving is not very big. So we have to decide our machine for the products we are making. The weft required to be inserted, we have to be careful when deciding a machine for what products we will be making. Will define if the air jet will be used or some other technology will be employed to make the fabric. Some faults are only related to air jet. For example, on the running machine, double wefts can be inserted if some parts of the system are malfunctioning, and these faults, a range of faults that can be present. Some signature air jet weaving faults are there, so we need to be careful about those also. In this slide, I want to explain the difference of timing with the other machines, and when some part of the compensation of air jet weaving start with respect to the degrees of the main shaft. On the left, you can see timing diagram of regular air jet weaving machine. We see this there: the shed opening, shed closing, beat up time. These are all like the other machines. Here we can see that the main nozzle is starting the air pressure before the shed opening. The shed opening starts at 90 degree, but the main nozzle pressure started almost at 60 degrees centigrade, 60 degree angle. Sub nozzles are following afterwards, that is something 65 degree, and the yarn is released from the yarn brake EFT or ABS brake, something 80 degree. At 90 degree, our shed starts opening, and when weft approaches into the shed in the region of the sub nozzles, shed will be sufficiently open that the weft will start inserting. And on the other side, if we see the shed closes at 270 degree here, so our sub nozzles is finishing the release of pressure before something 20 degree before. This is something 250 degree. So it means that the air pressure, the wefts start traveling before the shed opening, but before the shed close, the weft has been inserted. Here this confusion of the shed start open after the release of the weft, we can consider the figure on the right. Here we see that the shuttle is too big. we have to make angle, shed angle. This is the shed angle. We have seen this shed angle in the shed geometry portion. This shed angle is very high in the case of shuttle because the shuttle is very close to fell of cloth. This distance is the distance B is very almost would be the same like the air jet, but the requirement of shed angle is too high because shuttle is very big. While we need a profile read, for example, like this, and we need to insert only left on this portion. So we do not require a very big shed to open. A small shed to open. The opening is required. The small shed opening can adjust this difference that the weft start before the shed opening. So here I want to make this clear that where not very high angle is required by the machine to open at the front of the machine to let the weft insert by air jet weft mechanism. And I also discussed how different timings are generally on a air jet machine. This is the last slide of today. Here I want to discuss about the timing. I want to mention over here is that the relay nozzle works in group. This working in group is because we want our yarn tip to be accelerated and the remaining part, the part that is behind the tip, follow this acceleration. So we exert pressure only on at the tip of the yarn and remaining yarn follow along. In this way we prevent the buckling. Buckling means the folding of the yarn. If yarn get folded at any position in the weft insertion throughout the whole weft insertion from left to the right of the machine, this is not good and this will cause problem. When the snarl yarn or loop yarn, these loops can be on right side or left side or middle of the machine fabric width. So this buckling is prevented only if we need to exert pressure at the tip of the yarn that is being inserted. To make sure, what we do is we pressurize different sub nozzle only when the yarn would be available over here. For example, if yarn is available over here in this region, these pressure will be working. When the yarn approaches at this region, these nozzles will be pressurizing the yarn in the forward direction. And similarly, the next pair will be energized or pressurized when the weft will approach from here. And that's how our weft is inserted in the channel read that the yarn tip is pressurized. The yarn tip is pressurized so that there is no buckling and the remaining yarn follows the tip's acceleration. So in this way we can prevent very high use of the air pressure, and this helps us to optimize the use of the pressurized air. So and there is no buckling, there is no folding of the yarn also. So this is the basic requirement from the timing of the nozzles, that they work only when the yarn is present. They pressurize their tip so that their tip and the yarn tip would be accelerated in the forward direction and the remaining yarn follows it, and without buckling our weft is inserted. Thank you very much. With this slide I finish for today's lecture, in which I have described you about what is air jet weaving, how different components are involved, their working, our overview of the air jet weaving, its comparison, small comparison, and its requirements and limitations. Thank you very much. Assalamu alaikum.